Good morning, students. Welcome back to science class on the chapter electricity. In the previous class, we had studied system of resistance, that is resistors in series and resistors in parallel. Okay, so just recall what we had studied in the previous class. First, we will discuss resistors in series. Okay, so consider three resistors. All the resistors are connected in series. Okay. So I call this is R1, R2, and R3 voltage V. Okay. In series current is constant. In series current is constant, and voltage is different. Voltage is different. Okay. Across here, I call this as V1 and V2, V3. Okay. Next, how to calculate the voltage across resistor R1 and R2? For that, we have formula, that is V is equals to I into R. It's a very important relation. Okay, we use this formula to calculate the voltage, current, and resistance for entire circuit. For individual resistors, we use this one, V1 equal to I into R1. Okay, to calculate voltage across resistor R1, we use this formula, that is V1 is equal to I into R1. Here V1 is the voltage across resistor R1 and R1 is the value of this resistor. Okay, and the current, see here I have not taken what I1. Why? Because the current across the circuit and current across R1, R2, R3. Okay, so current is constant, so that's why here I have taken current as I. Okay, so next, suppose you want to calculate the voltage at across this resistor, so we use V2 is equals to I into R2. Okay, then for R3 we use V3 is equals to I into R3. Okay, in the previous class also we had studied what voltage in circuit, which is equal to the sum of the voltages across the individual resistors, that is V is equals to V1 plus V2 plus V3. Okay, when you add these values, so you will get the total voltage in the circuit. Okay, next move to resistors in parallel. Yes. So now consider the circuit. Here the resistors are connected in parallel. Okay. Parallel. Current is different. Why? Because here current divides into branch currents. Okay. So current is different. Then what about voltage? See, voltage across here or here or here. Okay. Voltage is constant. Voltage is constant. Voltage is constant. Now, if you want to calculate current here in this branch, okay, for that we use formula V is equals to I1 into R1. We need I1, right? So during R1, that is V divided by R1 is equals to I1, or I1 is equals to V divided by R1. If you want to calculate current I2, then we can write I2 is equals to V divided by R2. If you want to calculate current I3, so I3 is equals to V by R3. Okay, so here also same. The total current in the circuit is equal to the uh, sum of the currents across the individual resistance. That is, I is equals to I1, I2 plus I3. Suppose say just imagine here you will measure the current. Okay, negative. Suppose if it is here 6 ampere, then if you measure once again here also you will get 6 ampere. But if you measure here current, yeah, different. Maybe here 1 ampere and here 2 ampere, maybe here 3 ampere. We don't know. That depends on the values of the resistors. Okay, so in a parallel circuit, current is different, voltage is constant. Okay, and here also total current in the circuit is equal to the sum of the currents across individual resistor, that is I1 plus I2 plus I3 and so on. Okay, so we have discussed everything in the previous class. So now we will directly move to the problems. First, I'll write the question. First question. An electric lamp whose resistance whose resistance is whose resistance is 20 ohm, and a conductor of 4 ohm resistance are are connected are connected to a 6-volt battery as shown in the figure. Figure. Okay. Next. Calculate. First question. The total resistance. The total. The total resistance of the circuit. Difference across the electric lamp. Electric lamp and conductor. Okay. Signal lamp. Four. Okay. Yes. See, battery is 6-volt. See. Yes. So now here an electric lamp whose resistance, is of 4 ohm. Okay. So conductor, its resistance is 4 ohm, are connected to a 6-volt battery as shown in the figure. So calculate, first question, the total resistance of the circuit. So here, see, this is a conductor. Conductor, I have told, right, all the electrical equipments, they have some kind of appreciable resistance. Okay. So now here comes, this is a conductor and electric lamp. So resistance of the conductor is 4 ohm and resistance of the electric lamp is 20 ohm. But both are connected in series. Okay. Why? Because here joined end to end, right? So both are connected in series. First question, calculate the total resistance of the circuit. Okay. So total resistance. How to calculate total resistance? So now see here, I will take this as R1 and this as R2. Okay. Yes, so we have formula, right? When the resistors are in series, we use to calculate the total resistance, that is R is equals to R1 plus R2 plus R3 and so on. We use this formula to calculate the total resistance. Total resistance in the circuit means when the resistors are connected in series. Okay, we use this formula only for series circuit, not for parallel circuits. Okay. Now, so we know the formula here, only two resistors are connected, right? So we can write formula R is equals to R1 plus R2. What is R1 value? That is 4. What is R2 value? 20. So R is equals to 24 ohm. Okay. So total resistance in the circuit, that is 24 ohm. Okay. So now we can redraw this circuit. As here like this. Okay, so now we can redraw the circuit as, so now here 24 ohm. Okay, so both are same. Okay, so total resistance in the circuit, that is 24 ohm. Okay, next question. Second one, what is that? The current through the circuit. Okay, the current through the circuit. Here clearly we can say that current through R1 or current through R2 both are equal. Why? In a series circuit, current is constant. Okay. Yes. So now calculate the current. What is the current? Calculate the total current in the circuit. Yes, already so many students answered. Okay, very good. Yes, to calculate current, so we have formula, right? That is V is equals to I into R. We use this formula for the whole circuit. Okay. Yes, V is equals to I into R. We need current, right? Bring R this, that is V by R is equals to I. Or we can write I is equals to V by R. Okay. So substitute the values. I is equals to V is 6 divided by 24. 6 ones are, that is 1 divided by 4. So 1 by 4 is equals to 0.25. 0.25 ampere. Okay. So total current in the circuit, that is 0.25. Okay. So now here current across this resistor is 0.25. Current across this resistor also 0.25. Okay. Why? In the series circuit, current is constant in the circuit and also in the across the individual resistors. Okay. Third one, the potential difference across the electric lamp and conductor. See, total potential difference or voltage in the circuit is 6 volt, but we need we need voltage across the electric lamp conductor. Why? Here the voltage is different, right? Why? Because here both the resistors are connected in series. In series, voltage is different. So that's why. So now our work is to calculate voltage across R1 and R2 or electric lamp and conductor. This. Yes. So first we can calculate voltage across R1. Okay. So now can we draw this result, that is I, here also I, but voltage across R1, that is I'll take it as V1, and voltage across electric lamp I'll take it as V2. Okay. First calculate voltage across R1. For that we have formula V1 is equals to I into R1. Here current is constant, so that's why I have taken I. What is I? And then we got right, that is 0.25. And what is the value of R1? R1 is 4. Just tell me the answer. 0.25 into 4. Okay? Quick. Here, no need to multiply 0.25 into 4. See, just use 0.25. What is the answer? See, we can write 0.25 and like this, right? 1 by 4 into 4. 4 it cancel. Remaining is 1. No need to multiply 0.25 into 4. Okay? So answer is 1 volt. So voltage across R1 or across the conductor is V1. Next V2. So V2 is equals to I into R2. Current is same, right? 0.25 and voltage is 20. Okay. So V2 is equals to, here also same, 1 by 4 into 20. 1 by 4 into 20. 4 ones are 4, 5 are 195, 5. So V2 is equals to 5. See, just observe here. Now, we have studied, right, this formula. So we what is the what is the what is the reading what is the reading in ammeter in ammeter in the given figure. Ammeter in the given figure. Okay. First, tell me the answer for this question. Okay. What is the use of the ammeter? Quick, put it in the comment box. What is the use of ammeter, or why we need ammeter? What is the use of ammeter? I am waiting for your answer. What is the use of ammeter? What is the use of ammeter? Yes, it is used to measure current, electric current. Okay, so here we use ammeter to measure the current, right? So then we need the current in the circuit. Okay, yes, calculate the current quick and tell me the answer. First, yes, what is the answer? Current is 1 ampere. Yes, okay. So current in the ammeter, that is 1 ampere. See here, we need current, right? So for that we use this formula. V is equals to I into R. Clear? But here we don't know resistance, right? We don't know total resistance in the circuit, but we know the individual values of the individual resistors. We don't know the total resistance in the circuit. So first calculate the total resistance. How to calculate total resistance in the circuit? When the resistors are in a series, for that we have formula R is equals to R1 plus R2 plus R3 and so on. Okay, so here we have here only two resistors, right? So that's why R is equals to R1 plus R2. Okay, what is R1 value? That is 2.5. R2 also 2.5. So total 5 ohm. Okay, so now total resistance in the circuit is 5 ohm. Instead of using two resistors, you can use only one resistor. Okay, and value of that resistance should be equal to 5 ohm. So you can redraw this circuit as here like this. Now 5 ohm. R is equals to 5 ohm. Okay, yes, calculate the current. So we need current and bring down this side, that is V by R equal to I, or we can write I is equals to V by R. What is V value? That is 5 volt. R value is 5, that is 1 ampere. So total current in the circuit, that is total current in the this so the reading in ammeter, that is 1 ampere. Okay, yes, next one. See here now, calculate voltage. See here, 2.5 ohm, R1 equal to 2.5 ohm, R2 is equals to 2.5 ohm. See here, if you measure the current here, or if you connect ammeter here, here, or here, or here, or here, you will get the same answer. That is 1 ampere. Why? Because in the series circuit, current is constant. Okay. Now calculate voltage across R1 and the voltage across R2. So V1 and V2. Now calculate V1 and V2. Yes, fast. So calculate V1 and V2. Tell me the answer. Yes, the current will be the same everywhere. Very good. Yes. Now calculate voltage across R1 and voltage across R2. That is V1 and V2. Quick. 2.5 volt. Yes. To calculate V1, so we have formula, that is V1 equal to I into R1. Okay. So What is I value? That is 1 ampere. What is R1 value? That is 2.5. So V1 is equals to 2.5 volt. Next, V2. I into R2. I is 1 and what is R2? R2 is 2.5. So V2 is equals to 2.5 volt. Okay. So you can check. Okay. Then you are done in mistake or not. See, we know this formula, right? V is equals to V1 plus V2 plus V3. Okay. So what is V1 value? V1 is 2.5 plus V2 is 2.5. What is the total voltage? So V is equals to. So here also 5 voltage and 5. So clear, right? Yes. So next one. So once again same. What is the reading in ammeter in the given figure? Okay. Yes. Find it fast. At last, calculate voltage across R1 and R2. Tell me the answer, quick. First, calculate what is the reading in ammeter in the given figure. Okay. So here you should calculate current. So if you want to calculate current, first you should calculate the total resistance in the circuit. I is 0. 0 point, current is 0.5. Naresh Joshi. So I is 0.5 ampere. Okay. Yes, what about others? Anu Sangeet. Current is 0.2 ampere. So here we got two different answers. One is 0.5 and Sampath Kumar answered current is equals to 0.5 ampere. Okay. Wait for others. Yes, only 3 students responded. What about others? Okay, see here. First, calculate the total resistance. To calculate current, we have formula, right? That we have formula, right? V is equals to I into R. So V by R is equals to I, then I is equals to V by R. So voltage is 5. What about resistance? We don't know, right? The total resistance in the circuit. First, calculate the total resistance. That is R is equals to R1 plus R2. R1 is 5 plus 5. That is R is equals to 10 ohm. Okay. R is equals to 10 ohm. Substitute here. So that is 1 by 2. So I is 1 by 2 is equals to what? 0.5 ampere. Okay. So voltage current here, everywhere current is 0.25 ampere. Okay. Yes. And next we calculate voltage across R1 and R2. Next calculate voltage across R1 and R2. V voltage of R2 is also V 2.5. Okay, so here both are equal, right? 5 ohm, 5 ohm. Okay, both the ratios suppose the same, right? So definitely we can say that voltage across R1 is 2.5 and voltage across R2 is also 2.5. Yes, next one. R1 is 5 ohm and R2 is 10 ohm. Yes, what is the reading in ammeter in the given figure? And also calculate voltage across R1 and voltage across R2. Yes, what is the current in the circuit? Yes, three students answered. Nandini Power, your answer is 0.33a. Sampath Kumar 0.33a and Anu Sangit R1 is 1.5. What is that? R1 is 1.5 volt voltage. First calculate the current, okay? Naresh Joshi 0.33 ampere. Let's check, okay? For the whole circuit, we use V is equals to I into R. V by R is equals to I is equals to V by R. Voltage is 5. We need a resistance, right? That is R is equals to R1 plus R2, and R1 is 5 and R2 is 10. So R is equals to 15. Oh, substitute here. So 15, and that is you get 0.33 ampere. Okay, so total current in the circuit is 0.33 ampere. So current across R1 is also 0.33 and current across R2 is also 0.33 ampere. Why? Because here the resistors are connected in series. Yes, next we calculate voltage across R1 and R2. First, current is okay. R1 is 1.5 and R2 is 3 voltage. Is it correct? 1.5 and 3 volt. So V1 is 1.65. V1, V2. You know, right? We connect voltmeter in parallel. Okay, because we should have voltmeter which measures the voltage between 2 points, and we connect ammeter in series. Yes, V1. So V1 is equals to I into R1. I is 0.33 into R1, that is 5. Okay. Then V2 is I into R2, 0.33 into 10 ohm. Okay. Yes, quick. Tell me the answer. First, what is the voltage V1? V1 is 1.65. So 0.33 into 5. Yes, this is 1.65 volts. Then what about here? 0.33 into 10, that is 3.3. V2 is equals to 3.3 voltage. Okay, so now just check or cross verify. We know the formula V equal to V1 plus V2. V is what? That is 5 volt. What is V1? V1 is 1.65 and this is 3.3. Add 1.65 to 3.3. Okay, so 1.95. Sorry, 4.95. This is 5 and here this is 4.95. This is 5 volt and but both are not equal, right? But in a series, what V is equal voltage across voltage in the circuit, which is equal to the sum of the voltages across the individual resistors. But here we got 5, here we got 4.95. Okay, why? Because you know, see here while calculating current, you got 0.33333, right? Okay, so here we are consider only 2 digits, so that's why you got 4.95. So both are approximately equal. It is very less, right? 0.05. Clear? Yes. Next one. Next one, find the current through find the current through find the current through R19, R19, R2, also find the total. Yes, also find the total current, the total current drawn from the battery. The battery from the battery circuit. Find the current through R1 and also find the total current drawn from the battery, which means here you should calculate the current across R1, current in R1, R2 and total current in the circuit. Okay, but here the resistors are connected in parallel. In parallel circuit, current is different and voltage is constant. Here current here divides, right? So divides into I1 and I2. So once again you will get the here at this point you will get I. See here. So voltage is 5. Voltage is 5 and here also 5. Why? Voltage is constant in the parallel circuits. Okay, so we need current at R1, right? Through R1, right? For that we have formula V is equals to I1 into R1. Okay, so we use it for branch currents. Next we bring R this side. So we divided by R1 is equals to I1, or we can write I1 is equals to V by R1. What is the V value? V value is 5 and R1 is 5. Okay, what is the answer? So that is 1 ampere. Okay, V is 5. So answer is 1 ampere. So current through the resistor R1, that is 1 ampere. Next calculate second current through R2. So for that we have formula V is equals to I2 into R2. So V by R2 is equals to I2, or we can write I2 is equals to V by R2. What is V value? V is constant, that is 5, and I is also constant. Sorry. So here also you will get 1 ampere. So current through R1 is 1 ampere, current through R2 is also 1 ampere. Then what is the total current in the circuit? What is the total current in the circuit? For that we have formula, that is I is equals to I1 plus I2. What is I1? 1 plus 1. So I is equals to 2 ampere. Okay. Yes. Now calculate total resistance in the circuit. Now calculate total resistance in the circuit. Total current is 2 ampere. Yes, correct. So now calculate total resistance in the circuit. So now here resistors are connected in parallel. To calculate total resistance in the circuit, we use this formula, right? 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3 and so on. Okay? Calculate the total resistance in the circuit. Yes, the total R is 2.5 ohm. Okay? Yes. See here. 1 by R is equals to what is R1 value? That is 5 plus 1 by 5. What is the LCM? LCM is 5 only. So 1 by R equal to 5, 1 plus 1. That is 2 by 5. We need R, right? So now take the reciprocal. That is R is equals to 5 by 2 is equals to 2.5 ohm. Okay, see here you can calculate resistance using this formula also. See here V is equals to I into R. So you see earlier you have calculated total current, right? So that the total current is equals to 2 ampere and voltage, that is V equal to 5 volts. So now calculate resistance using this formula. That is V by I equal to R, or R equal to V by I. What is V value? That is 5, I value 2. So here also you get 2.5 ohm only. So to calculate total resistance, here you can use this formula or this formula, but you will get the same answer. Okay. I will stop here. Tomorrow I will continue the class. Thank you.